In this video, I want to give some general advice on how to prepare for an exam and what to do in an exam. Exams are a primary way to actually test your knowledge, your understanding of physics. It's not a great way, but it's kind of the least bad way that we have. So exams are a thing that you're going to have to deal with. So I'm going to give some general pieces of advice on how to prepare for them and what to do in the exam. I'm not going to be specific about, say, the next upcoming exam, so that this advice, applies to all exams. We can talk about the specific exam that might be coming up in a separate session. And this list of advice is something I've collected from talking to a lot of students in office hours, for example, and figuring out, why are people struggling? What can be done to help that? How can we make exams? How can we make people perform better in exams, especially when otherwise they're not that bad at physics? So the first thing is, before the exam, right, you want to focus on understanding the concepts. So focus on having strong conceptual foundations rather than spending your time trying to solve as many super hard problems as you can. Right? If you have no trouble with the basic concepts and all you can do is that remote challenging are super hard problems, then you're in good shape anyway and you don't have to worry. But the reason I want to emphasize the importance of the simple stuff over the complicated stuff is because difficult problems are really just setups that need to be broken down into a series of easy problems, right? So a problem is difficult because it might involve a number of steps, but if you really understand the concepts, you know what each of those steps is, and each of those steps is going to be easy. Whereas if you don't have a strong foundation and you try to solve some really difficult problems, maybe you somehow fudge your way through it, but presented with a new difficult problem, you won't know what to do, right? Because you lack that basis. So if you're limited for time, you probably are, focus on really understanding the concepts, on applying the basic relationships and equations, being able to visualize concepts as much as possible, and so on. It's a much better use of your time than trying to find the hardest problem that's out there. Next thing is you have to be honest with yourself and your own understanding, right? You want to understand your weaknesses and then you want to fix them. So one good way to do this is to go to the back of the relevant chapter in your textbook, and there tends to be a sort of conceptual question section. That's before the section on the main problem section. So those are just conceptual questions, maybe multiple choice, maybe just sort of open-ended. Read through them one by one, answer them, maybe in your head, but better to sketch down an answer on paper, maybe into some bullet points to really force yourself to express your thoughts. And what that'll do is it'll allow you to see what areas you're weak on. Right, so the point of doing that is that you can cover a lot of ground in a short amount of time, and that'll tell you, what you're still shaky on. And you're just doing this for yourself, so there's no point in fudging your way through it, thinking you just pretend that you know it or something, because you're not doing this for your instructor, you're doing this for yourself. So if you realize, hey, I think I know the answer, but I'm not sure, or you really just have no clue, well, that'll tell you, right, that there's something you have to work on, and then you can look at what concepts are involved in the question, like what is it asking me? Maybe there's some obvious relevant section number in the textbook, it allows you to fill the gaps in your knowledge. But you have to be honest with yourself here, right? It applies to all the work that you do. When you solve, say, old homework problems, this is the third bullet point here, do it. It's a great thing to do, but actually do it in a way so you get something out of it. So don't blindly work through them again the way you did the first time around. And if you can't get it, you look at the answer. If you do get it, great, right? Okay, it's going to help you a little bit, sure, but not very much. To make this effective, what you want to do is you want to really understand the problem and its solution more deeply than you did the first time around when you did it. The same thing applies if you do a problem you haven't done before. You're preparing for the exam. For every step, so maybe you'll be able to solve the problem, but ask yourself every step along the way, like, why am I taking this step? Like, why am I going from this line of algebra to this line? Why am I rearranging it this way? Oh, I want to isolate this particular variable. Why do I want to do that? Oh, because then I can eliminate it in a different equation. So ask yourself, why am I doing this? Why am I worrying about the forces left and right? And the second question you constantly want to be asking yourself, especially when you set up the problem, is how do I know this? So, for example, you have some statics problem with forces, and you ask, well, how do I know that the net force is 0 here? Oh, it's not moving. We're told it's stationary. You want to make that process very explicit in your mind. Maybe even write it down on paper. Because by seeing the underlying reasons for why you're taking a particular step, why this particular problem leads to a certain, mathematical setup, certain equations, if you can answer why, then you will automatically know in what other situation, what other problem, a similar reasoning might apply. Something I see very often is that in exams, having graded lots of exams over the years, is that students learn the procedure of one problem from the homework, say, and then blindly try to apply it to a different problem. And it's obvious, like the assumptions go into it in the solutions that I'm reading in the exam, and grading the exam, that have nothing to do with the actual setup of the problem. It's clearly something they sort of learned off by heart from a different problem. Okay, we did this there, we assume this is equal to 0, even if the problem they're doing right now is totally different. Right? Don't fall into the trap. If you understand why you're doing every step, then you know whether that same step or that same setup or that same assumption applies to a different problem, and you can correctly set those up. Now, if you can't solve a problem, so you go back to your homework, you do it, you can't solve it. Okay, go look at the solution, right? Figure it out. Make sure you understand every step of it. Again, ask the why and the how do I know questions as you look through a worked solution, maybe from your class notes. But then don't just move on to the next problem. Then you want to close your notes and rework the problem from scratch, including all the why and the how do I know questions, right? Because just reading it, you cannot be like, yes, I get it, makes sense, much like you might have done in a lecture. You sit there and you say, oh yeah, that makes sense. Doesn't mean that you understand it, doesn't mean you can apply it, right? It's a different game if you're the one having to come up with it, having to develop it from scratch. So work the problem again from the beginning, all the way by yourself. And maybe you need to refer to notes again. Maybe you got a bit further this time. Okay, open the notes, close it, go back a step. Work it without help from your notes. And then go back to the same problem the next day or maybe 2 days later, or something like that. And make sure you're still able to do it, right? You want to ingrain in your brain how to actually ingrain in your brain those methods that you learned, including all the whys and the how do I know and similar questions. Maybe even keep notes, right? If you want to go all out, you might sort of keep track of what questions you're still struggling with to do. Or same thing if you do a proof in class of some derive some equation. Can you derive it yourself from the assumptions? If not, where do you get stuck? Okay, look it up. Close the book, start again. Physics it seems to be all mathematical and rigorous and so on, but our brains are human brains, right? We learn a lot with repetition, we forget stuff and so on. So we have to accommodate that and work around that. So remind yourself, don't assume that just because you've seen a solution once, you'll remember it. You won't. It's not how the human brain works. Okay, so do old problems, but do them in a way that's actually productive. Another good way that's not listed here is, teach how to solve problems to other people. That will force you to answer those why and the how do I know questions. Another piece of advice is, that's the fourth bullet point here, give yourself a mock exam, like a fake exam, right? And maybe there are some old exams available, but also just pick a couple of problems from the book, say, you can sort of tell, are they easy looking, are they hard? Sometimes there's like some indicator of like the number of bars next to it. That gives you a rough idea of how hard they are. Just pick a couple and give yourself a certain amount of time. It doesn't matter if that is actually a good amount of time for those problems. The point is to work under some kind of time pressure in an exam-like situation. And whether or not you find your actual exam is open book or closed book, work those problems without reference to any notes. You really put yourself under pressure, do your best. If you get stuck, don't give up, right? Don't try to say, okay, it didn't work out, let me look at the notes. No, just keep working at it, figure it out. Pretend this is a real exam. See what you can get, see how far you can get. After everything is said and done, after your fake exam is over, sure, then you can look at your notes and fix everything. But when you do that afterwards, right, make sure you actually sort of check, okay, why did I get stuck here in my fake exam? What stopped me from going to the next step? What did I not see? Make it very explicit in your head. Write it down on paper. Right? Because if you made a mistake once, if you didn't see some connection once, or you misinterpreted something once, you're probably going to do it again. Unless you very explicitly tell your brain, oh, this is something I did not understand, now I understand it. These techniques are to some extent called metacognition. It's kind of a broad label for this idea of learning by reflecting on your own learning, on your own understanding. And that helps you learn. Helps you learn the material. So you can also give yourself a grade if you want at the end of it. Just to sort of see, okay, I got a 4 out of 10 here. It doesn't matter whether or not it's a good grading scale, or you don't know what grade you should give yourself. You can tell, has my answer improved from last time? And if not, what's stopping me? Do I still have the same hang-ups that I had before? If you want to make this more fun, do it with a friend. Nowadays, you might do it over Zoom, but you can sit there together, taking your exam, and afterwards you can discuss, right? Maybe even grade each other. Maybe it'll make it a bit more fun. But that helps you actually perform under exam conditions. Exam conditions are artificial. Real life isn't an exam, right? And you're learning physics for real life at the end of it all. But exams are what we got, right? So you got to make sure you're not doing worse on exam than you actually are at doing physics. Next point, right at the bottom, get a good night's sleep. It does not ever pay to cram until 5 a.m. right, the night before the next exam in the morning. Your lack of sleep is going to make it way worse than like not having covered some other detail or not having put that extra practice problem in. I've been known to say don't cram unless you haven't looked at the exam at all at the material at all until midnight before the exam. But even then, just cram until 3. And anyway, you should have looked at it beforehand. Okay, so that's before the exam. There's some advice, probably lots of other pieces of advice that I could give or others could give you, but I think those are important things so you don't waste time. You have a productive preparation. Let me go now to what you have to do in the actual exam, during the exam. One thing, make sure you have your coffee ready, or you've drunk your coffee before you start the exam, right? Make sure you're in the right mindset. You're okay. Take some deep breaths. You're going to do the exam now. Everything else doesn't matter for the next hour or 2 hours. Then, when you actually start the exam, skim through the entire thing first. Don't just start writing down. Just skim through it, what's in it. Get a sort of mental map of what you're being asked. Identify maybe the concepts for each question so that you can be like, okay, question 2 and 3, super easy. I can do those right away. I know exactly what I'm doing. Solve those first, right? You're confident you can solve them. Solve them first. They're ticked off the list. You don't have to worry about them anymore. And you probably feel better about it too. then as you work through problems, especially if they're longer ones, make sure your answer makes sense. Right? So, example I spell out here in front of you on the screen is, for example, numerical values. They'll be realistic. Right? So if you're asked to find the mass of this unknown type of atom, and you end up all said and done with 1.8 times 10 to the 6 kilograms. Well, that's about the mass of a house. You can look at it, oh, it is 1.8 times 10 to 1,800,000 kilograms. That is gigantic. That's not an atom. It doesn't make any sense. Similar, if you want to find the mass of a planet and you come up with 10 grams, probably wrong. Right? Sometimes you don't know. Sometimes there are things where you don't have a sort of natural intuition what they should be. Right? What's the strength of the electric field around a sphere with holding a certain number of coulombs? There's no sort of natural understanding of what it should be. Right? Okay, then you just have to make sure you do the algebra and arithmetic thoroughly. If you've got a symbolic question where you've got to answer something, symbolically find some expression, then you can at least check that the units make sense, right? So the example here that I'm giving is, imagine you're trying to ask to find the speed of an electron going around an atomic nucleus. You're given some, details about the atom and so on. And your final answer is that it's going to be the mass of the electron divided by the radius of the circle. Well, you don't have to know anything about atoms or electrons to know that that can't be right. Right? Because mass divided by radius would give you something in kilograms per meter. Kilograms per meter is not a speed. Right? So that just can't be right. So those are just some of the sanity checks you can do. There are other ones too. For example, where you can say, well, what happens if this force here goes to 0? Does the answer still make sense? So taking like extreme ends, like, or if this angle, like let's go take an example from mechanics. You've got you're asked to find the acceleration of something that's going down and sliding down an inclined plane. Well, you get some final expression, and then you can check, for example, if the angle is 0, so the inclined plane is not at all inclined, it's just flat, horizontal, then you better get 0 acceleration, because it's just the object's just sitting there. If your answer doesn't match that, if you plug in 0 angle and you don't get 0 acceleration, you probably did something wrong. Right? So that's another sanity check you can sometimes do. Next tip, don't get bogged down, right? It's an exam, and exam questions are designed so you can do them in a short amount of time if you understand what you're doing. So if you've been working through algebra for 3, 4, 5 pages, well, probably something went wrong earlier and you took some wrong turn and ended up getting lost in the woods. Okay, reset, maybe leave the question, come back to it later, or at least go back to the beginning, see if you can spot where you might have made a mistake. Maybe you just lost a square factor somewhere, like this, something to the power 2, and it sort of fell by the wayside as you went from one line of algebra to the next. That made all the follow-up algebra way more difficult. Who knows? Stuff like that happens to all of us. So double check your answers as you go along, but also have this sort of meta view of the exam that I'm not expected to work 6 pages of algebra here. Right? Something I must have gone wrong somewhere. Don't get demoralized. There are lots of questions on exams. If you don't know how to tackle one of them, that's no big deal. Just do your best and move on. Right? Everybody has that. You don't have to get everything 100% right to get a top grade. Also, just keep an eye on the time. Right? If you get bogged down in a question, it's okay to get bogged down, I guess, if it's the last one. Right? You answered all the easy ones. There's one hard one you're struggling with. Well, you can spend as much time on it as you want. Sure, but on the whole, be aware. Okay, I answered half the exam. We are only a third of the way through the time of the exam. Okay, I'm in good shape. If you notice that, you're 3/4 of the way through the time that you have, but you've only barely answered half of the exam, you're like, oh, wait a minute, I need to speed it up. So then you might want to say, okay, I'm going to quickly answer the remaining questions that I definitely know how to do, that are easy, then I can split up the remaining time over the couple of harder ones that are left, or whatever the particular setup is, right? Just be sensible about it. Keep an eye on the time. Don't lose points because you leave yourself too little time for questions that you could easily have gotten full points on if you only had answered them, say, in a different order. All right, that's enough for me. It's all very general, I understand that, but I think you can apply that to the particular exam that's coming up and any future exams, and we can talk about specific ideas, specific maybe review strategies in class, or our next class meeting online right now. All right, hopefully that was helpful, and good luck in your preparation.